The topic of power is fairly simple to understand, and it's something that we aren't going to see a lot very much right now, but it is an important idea to know about, and it will appear in the second semester of physics on electricity and magnetism. The idea is that power is the rate at which energy is added to a system, and in this case by a specific force or by a specific agent. And so when we think about it, you can either think about it in terms of the work done or the energy of the system. It's really equivalent, since otherwise the energy would be constant if you weren't doing any work. So we can define it in terms of a time derivative, and if we have a constant rate of work or constant rate at which energy is added to the system, right? This is the idea of a constant versus changing velocity, for instance, same thing. That as long as this is constant, we can then say the change in energy of the system is going to be divided by the amount of time, and that will give you the power. And same with work, that if you know the total work done over time, that would also give you the power, since work is pretty much just the change in energy of the system. So typically when you're when you are using power, you will be dealing with a constant rate of work such that you could actually use this. So to give you one example of a situation where we could actually talk about work, it's the idea of people running up the stairs. Now in this case, we actually have the same length of stairs. It's 10 meters in each case, and we have different times and different masses of the people. So you can think about this in terms of the work that they are doing, because they are exerting a force to drive themselves upward against gravity. Another way that I would choose to think about this is that they are actually increasing their potential energy. So in these first two situations, A and B, you have the same mass of person, but you have different amounts of time. So the time that it takes them to go up the stairs, in this case, you're going to have the same change in energy, right? These two, you actually have the same delta E system because they have the same mass and they went up the same length of stairs. But then the delta T is what you look at to give yourself power. So since this person was able to do it faster, the number on the bottom is smaller, which means this actually is greater power. Did the same amount of work in less time. Now, if we then compared these two, once again, we're using now the same delta E cis and delta T. Now we have the same delta T. However, here, because the mass is less, the mass is bigger here, the mass is smaller here, which means she has a smaller change in energy of the system because she has moved less mass up the stairs. So in this case, even though the times are same, the numerator is smaller in this case, so C is less power than B, even though they took the same amount of time. So you care both about the energy and about the time, and as long as it's a constant rate of work, a constant change in energy of the system over time, you can just do this division rather than actually doing a time derivative.